The Java Persistence API used to be a part of the EJB specification until the release of EJB3. But the specifications are still closely related, and as we saw in the four-tier architecture for enterprise applications, the business logic tier, where EJB technology resides, delegates certain responsibilities to the persistence tier, where JPA technology resides. In the context of Java enterprise applications, persistence refers to the ability to have data contained in Java objects automatically stored into a relational database. The technique used to do this is called Object Relational Mapping, or ORM. Essentially, it allows your business logic to treat the data in your relational database as Java objects rather than database records. The kinds of JPA objects that the Affable Bean project uses are entities. Entity objects represent the rows of a particular table. If session beans are the verbs of a system, entities are the nouns. Session beans represent operations, and entities represent data. An entity manager handles the CRUD database operations for the entity object. CRUD operations are accessed through methods in the session beans, which then delegate the operations to the entity manager. JPA has its own query language called JPQL. It's an SQL-like language that JPA uses to access data from the database. Besides JPA, there's one other specification related to the EJB specification that deserves mention here, and that is the CDI specification, which stands for Contexts and Dependency Injection. Dependency injection allows the container to instantiate a service object rather than forcing the client to do it themselves. This slide shows a simple example of this. Here's some code with a private variable named HelloUser of type HelloUserBean. This class represents the client, and the HelloUser variable will hold the service object. The type HelloUserBean is the interface. That's the kind of object the clients need because it will use the service object to invoke the method call sayHello. In this case, the injector is the EJB container. We know this because of the @EJB annotation on the instance variable. The EJB container will provide an instance of this client class with an appropriate HelloUserBean object that implements the sayHello method. Notice that the variable HelloUser is never initialized in this code. Often, instance variables are initialized in the constructor, but in this example, the variable is not initialized in the constructor. So here's a question for you. Suppose I remove the @EJB annotation, and suppose the instance variable HelloUser was never explicitly initialized. My question is, would this be valid Java code? In other words, would the code compile? And can you tell me why or why not? I'll give you 5 seconds to think about how you would answer this question, or you can pause the video if you like. 5 seconds starting from now. Okay, the answer is that the invocation of the sayHello method would cause a null pointer exception because HelloUser was never initialized, so its value would be null. When you see annotations such as @EJB, @resources, @persistence context, or @inject on variable declarations, it typically indicates that the implementations of those objects will be injected by the container rather than created in the current class. Let's review the EJB-related technologies that we've talked about and put them into the context of a typical Java web application. We have some clients, in this case controller servlets, that need to access data from the database. We don't want to do this directly because databases use SQL and we want to work with Java objects in our servlets. It's also a good idea to separate SQL from our Java application so that the two can change independently of each other. We don't want to have to rewrite large chunks of code if we change the database. To enable all of this, we create entity classes. Entity classes represent tables in the database. They provide getter and setter operations for each field in the table. Entity objects, which are the instances of entity classes, represent a specific row in a database table. A client would like to be able to obtain these entity objects so that they can be used or modified. To do this, we create session beans from the entity classes. The session beans encapsulate the database by supplying all the necessary CRUD operations, create, read, update, and destroy, to the client. The most commonly used methods in a session bean are query methods. These methods typically start with the word find, and they return either an entity object or a collection of entity objects to the client. There's one last piece of the puzzle we're missing here. A session bean is a kind of service object, and a controller servlet is a client object. A controller servlet has the session beans it needs as instance variables, but we want to make sure that the servlet has the correct implementation of the session bean. In fact, since the session bean has no state, we would like to give the servlet a singleton instance of the bean. To do that, we simply annotate the declaration of the session bean in the servlet with @EJB, and the container will automatically inject the proper instance using dependency injection. Finally, now we have a complete picture of how entity classes and session beans work together to allow clients to access the data in a data source in the form of Java objects. Entity classes are part of the Java Persistence API. They represent tables in the database. Session beans are a kind of enterprise Java bean. They represent CRUD operations in the database. And annotations like @EJB ensure that instances are injected by the container using Java's CDI technology.